Hey guys, my name is Trevor Sullivan. I'm a solutions architect with StratusGrid, and welcome back to our video channel. Thanks so much for joining us for another video. And what I wanted to talk about in this particular video is how you can use one of the AWS services called Amazon SQS, short for Simple Queuing Service, inside of a Rust application. Now, before we get into today's topic, I wanted to discuss a little bit more generally about what message queues are, as well as some competing products to Amazon SQS in the open source ecosystem. So, for starters, I thought something that would be kind of fun is to ask ChatGPT what a message queue is. So, let's start by asking, what is Amazon SQS and why do I need a message queue? And just to give you a little bit of context, the answer that I'm guessing it's probably going to give us here is something about decoupling application components. Essentially, what a message queue does is it kind of sits in between as an intermediary between several different application components so that they can be decoupled from each other and run and scale independently from each other. So imagine that you're building an application, something like YouTube, for example, where you upload video files up to a service, and then those video files are processed by a backend video processing service into a variety of different file formats for streaming to different types of devices. So you've got different resolutions, different codecs, different bit rates, and all sorts of different parameters that are used to encode those videos into different file formats. Now, the process of actually uploading the file to cloud storage is relatively simple and should be relatively fast. But once that video file has been uploaded into cloud storage, the actual processing of that video is what really takes a bulk of the time because of all the compute power that's required in order to convert a video from one format into different formats, right? And that could be one different format, it could be 10 different formats. All that takes a lot of compute power. And so what a service like Amazon SQS or any message queuing service for that matter allows us to do is to kind of separate the backend service logic that handles things like uploading videos and modifying video metadata and uploading thumbnails, descriptions, keywords, tags, all that kind of stuff, and the actual processing of the video files that we can do kind of separately, right? So we can create this work asynchronously. We can say, hey, this processing job needs to go happen, but we want that to be done by some separate application component. So when we're talking about Amazon SQS and other message queuing services, we typically have what's called a producer and a consumer. And looking through this answer here, I don't necessarily see any references. Let me just do a quick search for consumer here. So yeah, here it mentions processing in parallel by multiple consumers. And let's see if we have a mention of producers. So producers can send messages to the queue and basically queue up work. And then the consumers are the ones that are kind of taking work off of the queue and then actually performing that work. So to give you an example of the kind of YouTube type of system where we have producers and consumers, the producer could be what's requesting the video processing jobs to be performed. So after I go to YouTube Studio and I upload a video file through YouTube Studio, the YouTube Studio service could then create a bunch of messages in a queue that says, hey, there's this source file that's sitting in cloud storage here. I need you to take this file and I need you to convert it into this format. And that could be a message that gets put onto a queue so that a completely separate service that's running the actual video processing, maybe it's FFmpeg CLI, or maybe just some another Rust application or C++ application, something like that, that separate component can actually go out and do that work by grabbing a message off the queue and then running that process asynchronously on its own. Now, decoupling is very important when it comes to scalability. If you have a monolithic application where all that functionality of uploading files, changing metadata, uploading thumbnails, changing descriptions, tags, all that kind of stuff, and actually processing the video files into different file formats, now if I need to scale up the video processor, I also have to scale up all of the additional components that really are not using that much compute power. And so by using a decoupled mechanism or architecture for my applications, I can make sure that I can scale the components that need scalability, and then I can keep the scale relatively low and therefore the costs low for the components that don't necessarily require as much compute capacity. So that's why we want to use something like a message queue so that we can have a producer that sends some messages and queues up some work, and then we can scale up the service that's actually doing a lot of that compute heavy work and process all those videos. And there's lots of different scenarios where you might want to do this. I just use the video processing task as an example because video processing is a pretty notoriously compute heavy task, but this could apply to things like 3D render farms where you have to render out 3D scenes and 3D movies out of different frames, right? And so maybe you've got a scalable system that's rendering individual frames from a 3D scene from a tool like Blender or something of that nature. You might also have just raw data processing tasks where you're reading data from an analytics database, you're aggregating that data together, you're shipping off that data somewhere else, or generating reports from that data. There's lots of different types of tasks that are very compute heavy, take a long time to perform, could take minutes, could take hours to perform, depending on the size of the data and the amount of processing that has to actually happen. That would be good use cases for having message queues. Now, message queues themselves are actually a really simple construct, and that's why I actually really like message queues because they're very simple to understand. It's basically just a temporary storage location for a bunch of messages that you can queue up work on, and then on the consumer side, you can just spin up a consumer process. It just reads a piece of work off that queue. Doesn't matter which one, doesn't necessarily matter what order they go in. In some cases it might, but there's actually a queue type for that called first in, first out. But basically those consumers just go out and do a bunch of work, right? They say, hey, give me some work. All right, I'm going to go do that work. And so it's a very simple process to understand. And so by decoupling your application components, you not only have a very easy way to scale your application, but it's also very easy to develop too. It makes your whole development process much easier because now I can really separate the logic and actually focus on the logic for individual application components when I need to go update it. I don't necessarily have to comb through tons and tons of different code for all these different application components that I don't necessarily need to modify if I'm trying to modify, let's say, the video processor, right? I just want to focus on the code for the video processor, so I'm going to focus on the repository for that, go make some updates to that little component, and then I don't have to worry about all these other components that are irrelevant to that video processor. So there's a lot of benefits as far as just your development architecture goes to using a service like SQS. Now, something else you might wonder is what are some alternatives to SQS? If I don't want to use a managed service like SQS, what are some other things I could use? So let's ask ChatGPT again to see what its opinion is. So we'll say, what are some alternative open source services to Amazon SQS? And it's probably going to mention things like Redis, things like Nats.io, things like RabbitMQ. You see Apache Kafka shows up, Apache ActiveMQ. And there's Nats, sure enough, and there's Redis for sure. So there's lots of different messaging services out there that you can actually run independently. So if you're on maybe an on-premises architecture where you're running virtual machines and containers on self-managed Kubernetes clusters and that kind of thing, you actually have the ability to spin up open source message queues like any of these projects that are mentioned here. And these are great alternatives to using a managed service like SQS. But I just wanted you to kind of understand that there are other options out there. ZeroMQ is another pretty popular one. If you're a Python developer, there's actually a module out there called Celery that you can use as well. So a whole bunch of different open source options available, and I'm sure there's tons of commercial options out there as well. So make sure that you just do your research, kind of figure out what works best for your particular situation. But we're going to be focusing on using the AWS SDK for Rust, which was actually made generally available fairly recently. It's one of the newer SDKs that's available for AWS. And basically, it allows us to write highly efficient applications using the Rust programming language, which is a little bit longer on the compilation times, but after the application's been compiled, the actual CPU and memory resources that are utilized by Rust applications are actually very, very minimal. So you can run Rust applications that have been pre-compiled on, very small devices like Raspberry Pis and other types of embedded devices that don't really have a ton of compute power. Rust is an excellent language for that. And plus, even if you're running on a powerful machine like my 16-core, 32-thread desktop computer that I'm currently working on, my media workstation, I can still get a lot more throughput out of all that compute capacity that I have on this system by using Rust instead of a higher level programming language like Python or PowerShell or other types of interpreted languages. So Rust is an excellent programming language if you're looking to write highly efficient applications. Now, let's actually take a look at SQS for starters here in the AWS Management Console. So when you go into the SQS service, you can just search for that right up here. You get the SQS service and it takes you over here, and all you have is this button to create a queue. Or if you go to the hamburger menu here, all you have is queues. Now, a lot of AWS services will have like tons of different options in their menu here, but SQS, again, is very, very simple. It's literally just a message queue where I put some messages onto a queue and then somebody else takes messages off of that queue, right? So that's why the console is so simple here, because SQS by itself is actually a very simple service to use. So all we do typically is just hit create queue. Then we get some options here. We can create a standard queue, a first in, first out queue. So basically with a standard queue, there's no deterministic ordering. So if I put a message onto the queue and then follow it up with another message, that second message could actually be taken off the queue first before the first message is taken off the queue. But if you need to guarantee the order that the first message put onto the queue is the first message that's also taken off the queue, then you can use the first in, first out queue type instead. Now, you can also create a queue name right down here. So we just give it a name like, Trevor data or something like that. And then there's a whole bunch of configuration options here, and I'm not going to get too deep into what these configuration options are. Typically, the defaults should work just fine for you if you're just kind of playing around. You do have the ability to constrain the message sizes. If you know that your messages are only going to be a couple kilobytes in size, you can bump that down, things like that. I'm just going to leave it at the default, which is 256 kilobytes or a quarter of a megabyte. You can also enable encryption if you want to with the key management service or AWS KMS if you want to use a custom key. You also have the ability to define an access policy so that only certain AWS accounts, only specific applications running with certain identities are allowed to actually access the SQS queue. There's dead letter queuing, which basically allows you to take messages that are failing repeatedly for some reason and put them off into a separate queue for additional developer research or processing by some other kind of application component. And of course, as with most AWS services, you can assign, I think, up to 50 key value pairs or tags just containing metadata. I typically like to put an owner tag in there and just give it my name so that people know that I was the owner of this particular resource. But we want to actually create the queue and then send messages to it using Rust, not using the AWS Management Console. I just kind of wanted to show you what the structure of a queue looks like before we actually use the Rust SDK. Now, how do we use the Rust SDK? Well, typically, I would go out to Google here and say AWS SDK for Rust, and that's going to bring us to kind of the landing page for the AWS SDK for Rust. If you click on this orange button right here that says Get Started, this will take us over to the documentation for the AWS SDK for Rust. And something that's really nice about the Rust SDK team at AWS is that they have a whole bunch of code examples down here. And if you go to Actions and Scenarios, there's actually broken down by AWS service here. So if we scroll down to Amazon SQS right down here, it actually shows us exactly how to do things like sending messages and receiving messages. This is going to show us how to call the receive message API, specify input parameters like the message queue URL that we're going to be using to receive messages from. If we want to send a message to a queue, then we need to specify the queue URL, which includes the queue name, as well as a message body. There's also the ability to specify something called message attributes, which are up to 10 key value pairs that you can associate with a particular message above and beyond the message body itself. So it's kind of like having key value tags on the queue itself, but this is actually at the message level. So each individual message that you send into a queue can have its own separate set of attributes as well. So there are some advanced functions in SQS if you really kind of dig into the weeds a little bit, but we're just going to really focus on the fundamentals for this video, which is how to send a basic message with a message body, which can be things like XML, it could be JSON, it could just be unstructured text like hello from Rust or something like that. And so it's really simple to kind of get started. Now, they don't have a code sample here for creating a message queue with the AWS SDK for Rust. So How do we do that? Well, there's a couple of things that we could do to kind of further investigate how to create a queue. Number one is we could actually read the documentation for the AWS SDK for Rust, specifically the SQS crate that exposes the functionality for the SQS service. So what we would do is head out to the website called docs.rs. And this is also linked from crates.io, which is the central registry for Rust crates here. So let's say that we do a search for SQS on crates.io. So sure enough, there's the AWS SDK-SQS. If you haven't watched my other videos on the AWS SDK for Rust, then you might not know that AWS-SDK- is the standard prefix for any crates or modules that pertain to specific services for AWS. So if you see AWS-SDK-SQS, that's the official crate for the SQS service. Now, there may be some malicious actors out there that try to emulate crate names using that standardized prefix. So double check with the AWS documentation to make sure that that's actually a valid crate before you just go out and randomly start installing crates with the AWS SDK prefix on them. But I do know that this one is officially supported by AWS because if you come out to the AWS SDK for Rust site here, I think if we actually go back to the homepage here and you go to crates and API documentation here, this will actually take you to a website that's actually hosted by AWS Labs for the AWS SDK for Rust. And it actually has a list right here of all the different package or crate, in this particular case, we call them crates, names for the various SDKs. So if we just do a Control F in our browser and search for the SQS service here, sure enough, you can see that AWS-SDK-SQS is the valid crate name for this particular service. So you can always come out to this page. This is an official page that's hosted by AWS Labs that is responsible for the official AWS SDK for Rust. And so this will guarantee that those crate names are authoritative and are not being hosted by a malicious actor that's trying to pretend like they own one of the AWS SDKs. So make sure that you validate things through there. All right, so what we can do is go to this crates detail page right here. And then on the right-hand side, you can see there's a direct link to documentation, which goes to the docs.rs site, which we went to right back here. So we could also go to docs.rs directly, do a search for SQS, open up the AWS SDK for SQS right here, and then we can take a look at, let's go down to modules here, go to operations, and then we can take a look at the create queue operation here. So if we take a look at the SQS docs, okay, so here's the documentation for Amazon SQS, go to the API reference here, and you can do this for any AWS service, not just the SQS service, but what you want to do is take a look at the API reference documentation for the service and then go to actions here. And the actions are formatted a little bit differently, so they're in a different casing here, so you have like a capital letter for each of the words there. But as you can see, there's actually a API action here called create queue, and this create queue API action in the underlying REST API for the SQS service actually corresponds with the create_queue operation in the Rust SDK for AWS. So as you can see, we call create queue and it's a wrapper for the create queue operation. Then we can take a look at the inputs here. We can specify a queue name as input. We can specify attributes as inputs here. We also have the ability to specify tags. Those are the key value pairs that we can associate with a queue. So this is the kind of input data structure that we need to specify when we create a queue. Now, something else that you can do is go over to ChatGPT here, and let's ask ChatGPT. Since this is kind of the modern way that a lot of people are learning to code, let's go ahead and ask ChatGPT, how do I create an Amazon SQS queue using the AWS SDK for Rust? So let's see what ChatGPT says. It says, of course, make sure you have a Rust environment. So that is a very important thing. If you're brand new to Rust, then you want to go to rustup.rs and install the Rust SDK here, or the Rust programming language and all the tool chains for it. And so basically, if you just copy the script into your Linux system, this will get the SDK installed for you, or the Rust tool chain, I should say, not the SDK. So once you've got Rust installed, Then you should be able to run various tools like rustc -- version, which is the compiler. I should also be able to run cargo version and get the version of cargo. So as you can see, I've got the Rust toolchain installed right here. All that's good. But what we want to do is actually create a new project. And typically to do that in Rust, you do cargo new. That'll scaffold out a very basic application for you. Then we need to add dependencies. Now, what you'll notice is that the dependency versions that ChatGPT is aware of are a little bit out of date here. So ChatGPT is showing us in our cargo.toml file here, which is what contains our package metadata for our Rust crate, that the latest version it thinks is 0.6.0. But if we head over to docs.rs here, the current version is actually 1.28.0. And if you scroll down through the version history here, you can see that it's been quite some time since 0.6.0 was released. So if we go all the way down here and open up 0.6.0, you can see that that is a pretty old version here. So we're just going to say go to the latest version. And so just be aware that there might be newer crate versions for the SDK that you're trying to access. All right, let's go back to ChatGPT here and see what else it says. So it knows that we need AWS config. So this is a common crate that's needed for pretty much any AWS application that's going to be interacting with AWS APIs. This is how we load our SDK configuration for things like the region and authentication credentials with your access key ID and secret access key, things like that. And then also AWS SDK is asynchronous. And so the Tokio async runtime is very common with Rust applications. So if you're building any kind of asynchronous application, then Tokio is going to be a very common dependency that you come across for Rust applications. And then down here, it says, okay, once you've got these dependencies imported, then you can go ahead and start writing the application itself. So we've got a whole bunch of use statements up here to import various types. Then we've got our Tokio macro here that allows us to have an async main function. By default, you can't have an async main function unless you wrap it in the Tokio macro here or a different async runtime. There's some others out there like Smol, for example. But then down here, we basically set up our SDK configuration where we load our region and our credentials, typically from environment variables, although there are several different ways to load credentials. Then we load the client object from the SQS crate specifically, and we pass it in a reference. So we borrow the SDK configuration from this config variable right up here. Then we just define a simple string slice that contains our message queue name that needs to be unique here. Then we can specify attributes if we want to right here. Then we can specify the actual API call here. So client, that's our SQS SDK client. We call the create queue operation. Then we specify things like the queue name. We specify any attributes. You could also add tags in here or resource tags as well if you wanted to. Remember the input data structure that we saw over here in docs.rs for the create queue input here. We have the queue name, attributes, and tags. Those are the three different things that we can input. And all that corresponds again to the create queue API right here. So if we take a look at the request or input payload syntax here, we have the queue name, attributes as a set of key value pairs, and tags as a set of key value pairs as well. And if you need to configure the queue at all, so any of those configuration options that we saw inside of the AWS Management Console, like message retention period, the delay in seconds, the maximum message size, any of those kind of things, we can actually configure by using the attributes section right here. Those are different from actual message attributes, which are just key value pairs that you can actually set on individual messages. The attributes at the queue level actually configure the queue itself using these things down here. All right, so let's go ahead and actually build an application and see how close ChatGPT was to actually building a correct Rust application. And so what I'm going to do is fire up a terminal here. And I'm going to go into my Git directory at the root here. And then we're going to do cargo new SQS app. And that's going to create a new application here. And then I'm going to launch Microsoft Visual Studio Code into that particular directory. So now I'm done with that terminal. So I'll close it. And so now I get this basic application scaffolded out right here. So I've got my SRC folder with main.rs. This is where our application code is going to go. Also, I would point out to you that I am using Microsoft Visual Studio Code here. So if you're not using that, highly encourage you to use that. Go out to code.visualstudio.com and you can download it for Mac OS, for the Windows platform, for Linux. And after you've installed the Rust toolchain, you can actually go out to extensions here and search for Rust, and that'll bring you to the Rust Analyzer extension. And the auto completion that I get inside of the editor is actually based on the Rust Analyzer extension here. There's also a really useful extension called Error Lens, and I really like this one. I have this installed on my local dev system here because Error Lens will actually show me in line with the code itself what the error is. So normally in VS Code, if I don't terminate a line right here, for example, or if I have like a syntax error, it actually shows me the error in line here rather than having to go over to the problems screen here to actually see what the error is. So if your editor doesn't have the inline errors like I have right here, then you can install that Error Lens extension, and that should enable that for you. All right. So let's go ahead and start by adding in some packages. So we need to add in the AWS config package, and then we're going to add in this feature called behavior version latest. And in the AWS SDK for Rust specifically, just the AWS SDK, they expose this feature that allows them to have like breaking API changes between different versions of the AWS SDK. And in most situations, you're going to be fine just using behavior version latest. But if you don't specify that feature, then you are going to have to actually specify the behavior version in your application code. So by adding this as a feature for the crate for AWS config specifically here, I don't have to worry about setting the behavior version for the AWS SDK inside of my Rust code. So this is just a concept that's specific to the AWS SDK, not necessarily to Rust in general. So just be aware of that. We also need to add in Tokyo. So typically I do cargo add Tokyo and then features equals full. And it looks like we have an error here. That's actually kind of surprising. So let's see what is going on here. Let's try that again really quick. And it says failed to select a version for the requirement here. Okay, well, that was weird, but I went ahead and just ran a cargo update and then reinstalled Tokyo here. And it seems like that is working now. So some kind of weird temporal issue there. All right, so now that I've got Tokyo installed, I also need to bring in the AWS SDK for SQS specifically. So I'm going to say cargo add and then AWS SDK and then SQS. And as you can see, that works perfectly fine. So now in our cargo.toml file, we should be seeing 3 different dependencies showing up here. The AWS config base crate, the AWS SDK for SQS specifically, and then the Tokyo async runtime for Rust. So now we can go back over to main.rs right here. And if we take a look at our ChatGPT output right over here, one of the first things that we need to do is to append the async and Tokyo main macros to our main function. So what we'll do is say async function main, and then of course we're going to get this error here saying that main function is not allowed to be async unless we have an executor like Tokyo. So if we append that Tokyo main, you can see that that error goes away, and now we can successfully have an async main function here. All right, so the other thing that we need to do is to import some credentials so that we can authenticate to Amazon Web Services, right? So we need to be able to authenticate to our AWS environment from our application. So to do that, I'm going to head over to the Identity and Access Management Service. We're going to create a new IAM user, and then we'll go ahead and generate an access key. So let's say create user. I'll call this SG Trevor SQS-delete me. And then we'll go ahead and say attach policies, and I'm going to give this user account permission to the SQS service. And then I'm going to go ahead and hit next here and just say owner is Trevor Sullivan here, and then we'll hit create user. So now that I've created this user, I'll click on the view user button, go over to the security credentials right here. And if we scroll down to access keys, I can just hit create an access key We'll just say other, don't need to give it a description there. And then I can copy the access key ID and the secret access key. And then what I'm going to do is actually import those as environment variables. Now, one way to add environment variables into your application is to go into the standard library and go into the env module here, and then call the setVar function. And so then what I could do is say AWS access key ID is equal to this right here. And then I could duplicate that down a couple times for things like region and the secret access key. But it's not a good idea to put these credentials in our code. So a lot of programming languages out there, including Rust, have support for what's called a .env file. And so I'm actually going to be experimenting with this for the first time right here. If we go over to crates.io right here, there is a crate that's called .env right here. And this is a relatively up-to-date version of a .env crate without the Y on the end. If we just look at .env right here, this is much older, it's out of date, but .env here should allow us to load in a .env file in our project so that we can actually define our credentials as environment variables and avoid committing those into our Git repository. So essentially what we're going to do is create a new file at the root of our project and call it .env with no prefix on it. And then here is where we're going to say AWS access key ID equals this, and then AWS secret access key equals that, and then AWS region equals, let's say, US West 2. So now that we have this .env file, we're going to import another dependency here, which is .env. And then once we load .env, we can just call this line right here, and that will load the environment variables from the .env file, as long as that file exists and is accessible by our user account. So I'm just going to copy this line right here, and then we'll say cargo add .env into our application here. And then I'll just go ahead and replace this print line statement with this command right here. And what we can do is just return a result right up here. Let's just copy this example right here, and that should allow us to return an error. And we also need to import the standard error type right up here. All right, so looks like that's going to show an error there because we're not returning OK at the very end. So let's go ahead and just return OK on the unit type there. And it looks like it's complaining that the question mark can only be used in an async block that returns results. So let's see what's going on here. Okay, and the issue there is I just had appended a semicolon on the end here, so my function wasn't actually returning the OK wrapping the unit type there. So I just need to remove that semicolon, or I can do return explicitly there, and that will make everything okay. So now, somewhere in between returning from our main function and importing our .env file here, I need to go ahead and construct the SDK client. So to do that, I'm going to go into the AWS config crate and say load from env, and then we'll go ahead and await that because that's an async function, because we need to await it in order to actually execute the async feature. And then I'll assign the result to AWS CFG. So this variable AWS CFG will contain our SDK configuration. And then once we have that loaded, we can go ahead and create an SQS client. And what I typically like to do is say use AWS SDK SQS as something shorter like just SQS. So then down here, we'll say SQS client new, and then it will reference the AWS CFG right here. And then we need to assign this newly constructed client object to a variable so that we can actually use it. So I'll say let SQS underscore client equal the new client here. So now we've loaded our credentials as environment variables. We've constructed our SDK client that actually uses those environment variables to set the configuration. Then we created an SQS client from the generic configuration here, and we can reuse this generic configuration for other services. So if we needed to interact with SNS or S3 or EventBridge or any other services like that, we could just reuse this AWS CFG configuration here. But for now, our application is just going to use the one service, SQS. So now what we can do is actually go to this SQS client And if we take a look at ChatGPT here again, just to see what it says to do next, we could basically take this SQS client and then we call the create queue function in order to initiate a new create queue operation. Then we specify things like a queue name, optionally attributes, which we don't necessarily have to do. So we'll just kind of leave the attributes section off. Then we send the request and we await the future. So let's go ahead and give that a try. So we'll do SQS client dot create queue. Then we'll do dot queue name and specify a name here. So I'll create a variable here called queue name, and I'll call this Trevor Sullivan 123, put a semicolon there. And then once we've got this string slice containing our queue name, I'll just pass that in to the queue name function here to configure that request. Then I'll do dot send and then dot await. And then let's capture the result right here. So I'm actually going to take that question mark off and I'll say let create result equal the result here. So now we get this result, and that's either going to give us a successful output or it's going to give us an error message if an error occurs. So what I'll do is say if the create result dot is okay, then we're going to say print line created the SQS queue successfully and terminate that with a semicolon. All right, so this code right here from lines 14 through 18 is what actually instantiates a new request. It doesn't actually send the request until we call .send.await, but then we use a bunch of different functions like .queue_name here to configure the input parameters to the request. If you recall from the documentation, or create queue, which is the underlying REST API that we're calling, we have the request syntax here where we can set the queue name, we can set attributes, and we can also set resource tags, right? And so right now we're just setting the queue name, but we could also do things like .tags. We could also say .attributes and configure attributes or tags accordingly. But for now, we're just going to start with the queue name. And so this way, again, our credentials are sitting in the separate file, and we would typically put that into git ignore here. So we would ignore the .env file so that we don't accidentally commit that into our repository. So now our credentials are securely stored in this separate file that's not going to get committed into Git, and our application code here does not contain any credentials. So this would be a relatively secure way of structuring your application code and separating out your credentials. So let's go ahead and try this and actually see if it works or not. So back over in the AWS Management Console here, we're going to go to the SQS service, and we'll go over to queues right here. And as you can see right now, we don't have any queues. If I click refresh here, I'm in the Oregon US West 2 region, and there are not any queues in this account ID. So what I'll do is say cargo build to compile our application along with all of its dependencies here. And then after we build it, we'll just do a cargo run to actually test the application. Now, while that's building, I also wanted to point you over to an alternative to ChatGPT. So far we've just been using ChatGPT to ask some basic questions about message queuing, like what is message queuing? What are some alternative message queues to SQS? How do we write a Rust application using SQS to create a queue? But Amazon Bedrock is actually a managed service that is kind of designed to compete with ChatGPT to an extent, but it's not really so much consumer facing as it is more of a business facing service that you can build custom integrations with. So Amazon Bedrock, if you've never used it before, it basically just wraps a bunch of LLMs or large language models. And so if you get onto model access here, you'll have to make sure that you enable access to various models here. But once you've activated those models inside of your account, you can go over to the playground here and say, hey, I want to just, go around and ask some questions. So what I'll do is say select model, go to, let's say, Anthropic, and use, let's say, Claude 3 Opus here, which is a pretty good model. And then let's ask Amazon Bedrock, specifically the Claude 3 Opus model, how do I create an SQS queue using the AWS SDK for Rust? And let's just see how similar the answer is that we get through Bedrock using the Claude AI Opus model compared to the output that we get from ChatGPT. And just to give you a little bit of a cheat, answer here. I've actually seen much better results come from ChatGPT, as well as the user interface of ChatGPT being much nicer. So in general, I would not recommend using Amazon Bedrock for these kind of typical questions. If you are going to use Bedrock, I would typically use it more for building custom solutions than I would as actually using it kind of as an end user who's trying to get answers about common coding questions. So if we take a look, what we're actually going to see is that in our cargo.toml file here, they're actually recommending using an unofficial library called Risotto. I've never actually used this library myself, but that is an unofficial library that is no longer maintained. So if I go out to crates.io and I search for Risotto here, you can actually see that this is deprecated. It will no longer receive bug fixes. It hasn't even been updated in 5 years. So I would strongly recommend not necessarily taking the advice that you receive from a large language model at face value. Make sure that you do your research. Make sure you read the documentation for the SDK. Plus, the structure that they use here for creating the request and sending it is completely different than what they recommend using in the current SDK versions. So this is a bit out of date. I would not recommend using it, but it's still worth an exercise to take a look at it just to see what kind of output we do get from it. All right, so over here, we've built our application. So now let's just I'm going to refresh just to show you there's no smoke and mirrors, and then we'll do a cargo run to execute our application, and it says created the queue successfully. And now if we come back here and refresh, at least after a few seconds, that queue should eventually show up right here in our list. Now, sometimes the SQS service can have a little bit of a delay to it, but it does look like that message was, or the request was successfully sent. So after we've created the SQS queue, one of the things that we'll want to take a look at is what the actual queue URL is. And so the queue URL is what we use to actually send requests to the queue, like sending a message to the queue or receiving a message from the queue and things of that nature. So there, after maybe like 30 seconds or so, my queue finally showed up here. And so now that we've created this queue, you can see that we've got this queue URL. But we want to get the queue URL programmatically. We don't want to just copy and paste it directly from the user interface. So what we can do is actually inspect the output from this result here. So we have this create queue output object. And if we take a look at the documentation here and take a look at create queue output, this is going to show us that we get just a single property, which is a string wrapped in the option type. So with options in Rust, we can either have some of a value or none of a value. It's basically an enumeration that allows us to either have a value or not have a value. It's kind of almost like having null versus not null values, so to speak, but it's just a different way of doing it in Rust. And so the option type is wrapping a string that may or may not exist, and it's the queue URL on this output. So to do this, what we can do is say, if the result is okay, then we want to get createResult.ok. That's going to return the creation to us. So I'll assign that there. And then I'm going to go ahead and unwrap that as well, because the create queue output itself is actually wrapped in the option type right there. So we want to unwrap that so we get the create queue output. And then we should be able to print line, create a placeholder, and say creation.queueURL.unwrap. And we have to call unwrap anytime that we have an option, and we know that we have some value. We have to unwrap that value from the option to get the underlying string value. And then we'll say the newly created queue URL is : and then that's our placeholder there, so that whatever the new queue URL is will get printed out. And then I'm actually going to take this and assign it to a variable instead. So I'll say let queue URL equal that value, and then we'll just pass queue URL into the print line statement here. And so that way I can use the queue URL again later on in my program if I want to do things like sending messages, for example. So let's go ahead and do a cargo run. And you might say, well, Trevor, that queue already exists. Aren't you going to get an error when you try to create it again? And the answer is actually no. The way that the SQS service works is that if you call create queue on an existing queue, it'll actually basically indicate that it was successful. It'll kind of create the queue over top of itself. I don't think it results in any data loss, but as you can see, we were able to rerun that program as many times as we want to, and it just continues to return the queue URL to us. So it is technically valid to create a queue with the same name, even though the queue actually already exists. All right, so now we've got the queue URL. So now that we have the queue URL, we can use that to send a message into the queue. So the next thing I'm going to do is, once again, go ask ChatGPT here. Now that I have a queue, how do I send a message to an Amazon SQS queue using the AWS SDK for Rust? And let's see what it tells us. So once again, make sure you have a Rust environment, add your dependencies, which we already have. Then it's going to tell us this time you are going to create the SQS client and call the send message method to send a message to the queue. Then it gives us an example of how to accomplish that. It assumes that you already have a queue URL, which we already got by calling the create queue operation. We can define another string slice here, just containing a static string with an input message here that we want to send. Then this is the key difference here, right? So we take the SQS client object, and rather than calling create queue, we say send message instead. And then if we take a look at the documentation for the send message API over in the API, the REST API documentation here, we can see that in the request syntax here, there's a whole bunch of optional things, but really what's mandatory here is specifying the queue URL so we know which queue we're sending the message to. And then we also need to have a message body. So if we click on message body, you can see it says required yes. But most of these other properties like message attributes or delay in seconds, it says required no. So just make sure that you take a look at the REST API documentation and it'll tell you which of those inputs are required or which ones are not required. But in this case, we just need the queue URL and the message body. So once again, we're going to say inside of here that we want to take the SQS client and we want to call the send message API. So let's do SQS client dot send message, and then we would need to configure this request. So we say dot queue URL, and then we'll pass in the queue URL variable here. And then for the message body, we can go ahead and just specify a static string like hello from the AWS SDK for Rust, and then maybe put a crab in there as well for good measure. And then we'll do .send.await, and that will cause the future to get executed. So send creates the future, then await awaits the future, and the async runtime, in this case Tokyo, will execute it. So let's do let send result equal the result here. And then we'll say if send result.is okay, then we'll say print line message was sent to the queue successfully. And then we'll put another crab there just for good measure. All right, so now we'll go ahead and save this and we'll do a cargo run here. And it's going to try to create the queue again. It'll get the queue URL back, and then it'll send a message. And it says, message was sent to the queue successfully. So how do we validate that? Well, one, we could write some code to receive a message off the queue. Or what we could do is go over to the AWS Management Console for that particular queue, right? So we go back to our queue list right here. And once we're in the queue list, we open up that specific queue and we say send and receive messages. And down here, we have the option to receive messages. Up here, if you want to send a message just to test the queue out without having to write any code, you can certainly send a message to the queue if you would like to. But under receive messages, you can see it says messages available is 1. And so what we can do is say edit poll settings. And I'm going to poll for, let's say, up to 60 seconds. And I'll return up to 5 messages per poll. And so I'll click on poll for messages, and we only have 1 message available, so that's what shows up right down here. So we could check this box, and then we could optionally hit the delete button here to delete that message from the queue. It tells us the message ID as well as the size in bytes of that message. So now we have 0 messages, but if we run our application again, we're going to send another message into the queue. And because the polling is still happening, that new message just pops up right here. So let's open up this message, and you can see it says, "Hello from the AWS SDK for Rust." If we go to attributes here, you can see we don't have any attributes because we didn't assign any for that message. If we go to details here, we can see exactly when that message was received and things like that. So this is just a bunch of helpful metadata about that particular message. So we can validate that our Rust code is actually working successfully here to so far create the queue and send a message to the queue. But the third thing that we need to do is actually to receive the message off the queue. So let's pretend that we're writing in a different application, a consumer that's going to consume messages off of the queue. So we've got one application that sends to the queue. We've got another application that receives off the queue. So that's what we're going to do now. And keep in mind that when you receive a message off the queue, after you're done processing that message, let's say processing takes 5 minutes, right? It takes like 5 minutes to do some kind of video or audio conversion or something like that. You also have to call another API to actually delete that message off of the queue once it's been processed. Otherwise, the queue actually thinks, it assumes by default that the message processing has failed. So something happened on the consumer side that failed, and so therefore the message needs to be reprocessed by the system. So it'll actually put that message back on the queue until you call the delete message API call. So to receive a message, we need to receive the message and then delete the message after we're done processing. So let's go back to ChatGPT here. So now we've got sending message working just fine. How do I receive an Amazon SQS message and delete it using the AWS SDK for Rust? And let's fix that there. Okay. And it says to receive a message and delete it, you need to follow these steps. So once again, set up your Rust environment, add your dependencies, write the code. And in the code here, we have receive a message. And then if it receives some messages here, then we also need to call the delete message API right down here. So to delete a message, we need to specify the queue where that message was found, as well as this input called the receipt handle. And so the receipt handle is actually an attribute of the message when you receive the message. And so we use that receipt handle to actually delete the message after the message has been processed. So let's go ahead and give this a try in our Rust application code. So back over here, I'm going to go ahead and let's say comment out this code that sends a message right here. Well, I guess we can keep that. And then we'll go ahead and write some more code that says SQS client dot receive message dot queue URL. And this is going to be our queue URL that we already have in a variable right here. Then we're going to do .send .await, and we'll say let receive result equal the output here. And I like to just put each of these on a single line here just to make things kind of easy to interpret here. And because queue URL is already being used here, I'm just going to go ahead and clone it there, and then we can reuse it right down here again. And then after we get the receive results, we'll say if the receive result is okay, then we want to delete that message off the queue. So then we'll do SQS client dot delete message. We'll do .send .await as is typical. Then in order to delete a message, we need to pass in the queue URL. We're going to pass in the queue URL again. So let's do a .clone here. I'm actually going to see if I can borrow it really quickly with an ampersand instead of cloning it and see if that works. And it looks like that might work okay here. So then we'll assign the result to delete result and set that there. And since it works to borrow it here, I'm also going to borrow it up here instead of cloning it just for performance reasons. To put an ampersand up there. And so now we also need to specify the message receipt handle. And so what we need to do is specify dot receipt handle, and then we need to pass in the receipt handle from the message that was received right up here. So in order to get the receipt handle, let's say that we want the receive output to be the receive result dot OK. So that will give us the receive message output object that's being wrapped by the result there. And then because it's wrapped in an option, we also need to do dot unwrap on it. And that'll give us the receive message output object right here. And then if we go to docs.rs over here and take a look at the receive message output, let's do a search for that here. And there we've got operation receive message output as a data structure. So that has a messages field. And then that points to an option of vec message. And the reason it's vec message is because when we receive a message off of a queue, we could actually get anywhere from 0 to 10 messages from that queue. So if there's no messages on the queue, we could get 0. If there's, let's say, 5 messages on the queue, we could get 1, we could get 2, we could get 3, we could get 4, or we could get all 5, or we could get anywhere up to 10 messages per batch that we're receiving. So the vec is kind of like having an array around individual messages. But in this case, we're only probably going to be getting a single message because of our application is only sending a single message at a time. So what we want to do is grab the first message. So we'll say receive output dot messages, and then we're going to unwrap that because it's in an option type. And then with the vec, we are going to say, give me the first item from there. So let's say let MSG equal the output from that. And so that's going to give us an option with a reference to the message. And then we'll say dot unwrap so that we get the underlying message here. So now we should have MSG dot receipt handle. And so sure enough, there is the receipt handle. So what we want to do is actually pass that into the receipt handle method down here where we're configuring the delete message. So what we'll do is say MSG dot receipt handle, and then that's going to be wrapped in an option as well. So we'll unwrap that. And it looks like we are getting an error here. So it looks like we need to do dot as ref in order to get that. So let's try MSG dot as, or actually receipt handle dot as ref, and then unwrap that. Okay, so that works just fine. MSG dot receipt handle dot as ref, and then unwrap that. And I'm actually going to assign that to a variable just so we can visualize this a little bit nicer. So let's say our handle equals the output here. And so that gives us a borrowed string. And so then we'll just take that and pass it in to receipt handle here. All right, now all the grayed out code here, just so you know, is not actual code in my file. Those are inferred data types from the editor itself, Visual Studio Code. So all the light colored text here is my actual code, but then any of these data types here that are kind of grayed out a little bit are actually being inferred, with the exception of delete result right here. That's my actual variable name, but I can't actually select any of this other text because it's not technically part of my application code. All right, so let's do a quick review here and see what we've got. It looks like we have a little bit of an error message here. It says temporary value dropped while borrowed here. And so it looks like this is being freed at the end of this statement. So I think what we can do is just say, take this and then do messages equals the messages here, and that'll give us the vec of messages. And then I think we can take messages and grab the first and then unwrap that. So if we separate that out into two separate statements, that should work fine. Let's do a cargo build here, see if we get any compilation errors. Hopefully we don't. Looks like that worked fine. I'm going to go back to my message queue here, and I'm going to make sure that we have deleted all messages here. So it looks like we have one message. I'm just going to go ahead and delete that. And so now we're back to having 0 messages in this queue. So our application should just send a message to the queue and then immediately receive that message and then delete it from the queue. So let's go ahead and do a cargo run. And as you can see, it says message was sent to the queue successfully, and it should have immediately deleted it. So if we pull for messages here, we can see that all those messages are actually gone. And so we are actually running through this entire process of sending, receiving, and then finally deleting a message. Just to confirm that, I'll say if the delete result is okay, then let's go ahead and just print out a line that says print line deleted the message successfully with receipt handle, and then scroll down so you can see that there. And then we'll put in a placeholder and we'll pass in our handle there so that we can actually see what the receipt handle of the message is. And every time that we run this application, we should see a unique receipt handle coming back from the message queue. So as you can see right now, our receipt handle is this right here. It's kind of like basic 64 encoded string, kind of looks like, but if we run this application again, you can actually see that these characters have changed. So previously it ended in NKSYRA, but now it ends in L01 PB8W. And if we run it again, it's going to have a totally different value here. So we can see that this receipt handle is actually changing, and it's coming back from receiving the message off of the message queue. So anyways, it's up to you as far as what you want to put into the actual message body for your messages. At the moment, we have just hard-coded a message body that says hello from the AWS SDK for Rust, but in your application, you could put any kind of data in here. You could put in, for example, link to an S3 object that needs to be processed. If you upload a video file or some other huge data file, like maybe a Parquet file, up into Amazon S3 object storage, and you need to do some processing on that file, you could actually just send a message into the queue with a link or a URL to the S3 object that needs to be processed, and then your consumer application can read that message off the queue, take that message body, and actually go do some kind of data processing with it. So it's really up to you to kind of customize the actual data that's being sent into the messages, and then what you're actually doing with the message data once you actually receive the message off of the queue and read the body from it, and then actually process whatever's inside of that message. That's entirely up to you or your creativity as a software developer. But this just shows you the basic structure that we go through to use Rust in order to create a queue, to send a message to a queue, to receive a message off the queue, and then finally, after the message has been processed, finally, we just delete that message off of the queue. So in any case, I hope that you learned something new from this video. Thank you so much for joining us for another video on the AWS SDK for Rust on the Stratus Grid video channel. Thanks again, and we'll see you in the next video. Take care.